Hi guys, and welcome to PyMath. In today's video, we're going to be proving the identity that cos A multiplied by cos 2A multiplied by cos 4A multiplied by cos 8A multiplied by all the way until cos 2 to the power of n minus 1A is equal to 1 over 2 to the power of n sine A multiplied by sine 2 to the power of n A. Alright, so the first thing we need to do when solving these types of questions is we're going to identify what formula we're going to use to prove this identity. And I've already written it down here. It is sine 2a equals to 2 sine a cos a. Another thing we need to do is determine the number of terms in the sequence. Alright, so we have cos a, or if you can write it this way, cos 2 to the power of 0 a multiplied by cos 2 to the power of 1a, which is 2, multiplied by cos 2 to the power of 2a, which is 4, multiplied by cos 2 to the power of 3a, which is 8, and all that until cos 2 to the power of n minus 1a. Alright? So as you can see, these exactly match these, right? So we're just modeling the sequence out in the form of like 2 to the power of whatever. Yeah. So now I'll write down the term numbers for each of these terms. So this is term 1, this is term 2, this is term 3, this is term 4, and and we'll find out what term this is later. So you may notice a clear pattern that this term is always 1 less than this term. For example, 0 is 1 less than 1, 1 is 1 less than 2, and 2 is 1 less than 3. Using that same logic, we can deduce that this number is 1 less than this number, and n minus 1 plus 1 is n. Alright, so this is the nth term. Alright, so now that we've gotten that out of the way, let's move on to actually solving the problem, now knowing that there are n terms in this sequence. Alright, so let's just write it down once again. So cos A multiplied by cos 2A multiplied by cos 4A multiplied by cos 8A multiplied by multiplied by cos 2 to the power of n minus 1A. Alright? So what we're going to do is we're going to multiply this by 1 over 2 sine A. Alright? So we're just going to multiply this entire thing by 1 over 2 sine A. And to counterbalance that, we have to multiply this again by 2 sine A, because theoretically they could just cancel out and you'd be left with the same value. So doing this really makes no difference, but it's beneficial when we're solving this problem. So now that we have this, let's just write the rest of the sequence. So 2 sine A multiplied by cos A multiplied by cos 2A multiplied by cos 4A multiplied by cos 2n minus 1a. Alright, and we can simplify this into sine 2a, just like it says in the formula up here. So when we do that, we get 1 over 2 sine A multiplied by sine 2a cos 2a multiplied by cos 4a multiplied by cos 2 to the power of n minus 1a. Alright? So I don't know if you've caught on by now, but what we're trying to do is make it just like this formula over here. Right? So we'd want to make this into this so we can simplify it into this. But it has the sine part and the cos part, but it doesn't have the 2 part. So if we just multiply this and the denominator over here by 2, they could cancel out, meaning we can do that. So we can just write 2 sine 2a and 2 squared, because 2 times 2 is 2 squared, right? So I can just write 2 squared multiplied by 2 sine 2a cos 2a, which can be simplified to 1 over 2 squared sine a multiplied by 2, multiplied by sine 4a multiplied by cos 4a multiplied by multiplied by cos 2n minus 1a. And we can essentially just copy paste and do the exact same thing. So we're just going to do 1 over 2 to the power of 3 sine a is equal to 2 sine 4a cos 4a, which is, let me just erase this, which is, that is cos, that is sine 8a, and we can just keep the sequence going. The next term would be cos 8a, and then we can just keep it going until cos 2n minus 1a, right? So if we just keep on expanding this further until we do this n times, because there are n terms, as I said earlier. If we just do this n times, I think you can see that each time we do this, this gets bigger by 1. So if we do this n times, that would be 1 over 2 to the power of n sine a, and that would be multiplied by 2 sine 2 to the power of n a, because we do this n times. So it's basically like, it's like this logic over here and over here. We do it n times, so it becomes 2 to the power of n a. So that's how we arrive at that formula. If you enjoyed this video, please like and subscribe, and thanks for watching.